Good morning, everyone. My name is Sachin Sanghi. I've been with Siemens for the past 10 years, and I'm with Siemens Digital Industry Software. I look after our cloud products, namely Mindsphere and Mendix. I'm very thankful to ET Auto for organizing a forum which gives a chance for the entire ecosystem to come together and discuss the challenges and opportunities. I'll jump right into my talk for today. And if I take into context the current automotive industry trend, which is CASE, we are well aware of the acronym, which starts with connectivity, autonomous vehicles, smart mobility, and vehicle electrification. And this is causing a massive disruption in the classical sense of the automotive industry that we all know about. So if we look back how it all started, so the connected vehicle has been available for the past 25 years. Back in 1996, when Google Maps was not even launched, General Motors had a connected vehicle offering called OnStar, if some of you could be familiar with it. And this was a factory fitted telematics unit, and it came with factory fitted connectivity. So the way the architecture worked is some of these cars will be connected vehicles, and they would essentially connect with the mobile tower and give the driver a hands-free voice interface. And once the driver called, who was on the other side was a call center. And this call center representative would be able to provide certain services to the driver. So this was one of the first commercial offerings on connected vehicle. And the kind of service offerings that were available were essentially location tracking and emergency management. If the airbag went off, let the police or the airbag or the hospital or the fire department know. It also had some ability to carry out remote diagnostics. It provided services like deliver flowers or book cinema tickets, book a hotel room, and other things like that. But 25 years is a long time. While the genesis was like that, when we come to 2020, this particular domain has seen or continues to see a lot of evolvement. Today, talking about connected vehicle it is very difficult to not consider the connected entire mobility ecosystem because of the various advancements that have happened in sensors and computing technologies and cloud computing and whatnot. I will just give you one view. This is by no means the only view or the broadest view, but I'll give you one view about what are the different things that need to be considered in the mobility ecosystem architecture. So, in the center, of course, you have your vehicles, whether it is two-wheelers, commercial vehicles, passenger vehicles, and there are various ways that they are connected now. One is the telematics part, but however, these vehicles need to be serviced, they need to be repaired, they may be part of a garage or a fleet. They may be part of shared mobility. So they need to go back to fleets in the depots. And that also needs to become part of the connected mobility ecosystem. A lot of these vehicles are going to run on alternative fuels. And even if they run on the diesel, the CNG, and in the future electric, that infrastructure management needs to be done for these vehicles. There has to be an integrated payment gateway for the users that will be using these vehicles. So similarly, there is a vehicle to X, which is vehicle to other infrastructure, which can help you arrive at things like intelligent traffic management. There are advanced analytics, vehicle diagnostics, predictive maintenance, alerting the driver, assisting the driver, driver behavior, managing the battery for electric vehicles. At Siemens, we also have the concept of digital twin. We have a lot of software technology that helps uh, conceptualize these designs in the first place, do their analysis, and also virtually manufacture them in factories and before they actually get manufactured. And now, as these vehicles are running, the data that they are generating can be fed back to these design digital twins and engineering digital twins, right? So each one of these topic in itself is a vast topic, and I think it's a very, very exciting topic. If you just take one portion of the architecture that I talked about, which is V2X, vehicle to X, you can see that one needs to think in a larger terms. Your vehicle is not necessarily the individual vehicle that you own is sitting in the garage, or the vehicle is not necessarily a fleet of radio cab provider. But when we are talking about vehicles, these are public transport vehicles. These could be air transportation vehicles, water transportation vehicles, intersection assistance, autonomous driving, urban solutions, parking solutions. There is a lot that a connected vehicle really needs to do. The connected vehicle in the future is really going to work very hard. And all that hard work is going to make all our lives easier. They're going to make our environment better. They're going to help us consume a lot more services, make our times that we spend in the vehicle commuting from one place to another place. They're also going to help them make it more productive. If we move on to the connected infrastructure, and I know we are talking about connected vehicles today, but just to talk about a more aggregated view, a lot of the electric vehicle infrastructure really, the vehicle is just a part of a larger mobility ecosystem, right? So starting right from the non-renewable sources, which is the majority of the power grid that comes in, to the renewable power you're generating, to scheduling your vehicles, dispersing them in the chargers, making sure that at that time when electricity is the cheapest rate, at that time you maximize your charging while at the same time keep your fleet running up 100% of the time. Such solutions are enabled today if you have a connected infrastructure. There are ready-made solutions available to manage such fleets, such depots, and such charger managements, right? Likewise, we can deep dive into each one of the topics, but moving back a little to or contextualizing more to our geography, India. Where do we stand with respect to that, right? So 2018, as we are all aware of, there was an excellent start with the AIS 140 regulation coming in, and then we've seen some fantastic adoption. If anyone looks at the sheer number of startups that provide the track and trace service in India, it's very exciting to see. However, we have had an excellent start, but we definitely need further requirement. We as a country, we've got a lot of exciting things coming out of in this particular domain, but we need to be ready not just to utilize the existing 4G technology, but also keep an eye for the 5G technology. The opportunity here is massive. There are over 300 million vehicles on Indian roads. We have a complete ecosystem, and it is flourishing. If you are a fleet operator today, you can look at very innovative solutions on how to optimize your costs, optimize your trips, do predictive maintenance, extend the life of your equipment. If you are a telematic service provider today, you have a lot of ability to integrate your offering with various other offerings that are required in order to, complete the connected mobility ecosystem. So just providing tracking tracing may not be a successful commercial model anymore because you need to provide additional digital services in terms of like optimizing the routes and other things we talked about. Strategic partnerships between the ecosystems will become necessary, and I certainly see that there will be some very interesting partnerships that may come out with relatively smaller startups with a larger you know technology providers. Siemens provides a lot of platforms. We have a platform where a lot of startup telematic service providers can join us and enjoy the industrial connectivity that we offer across the board. In our markets, there could be long-standing old OEMs having partnerships with more newer age companies. These solutions, however, will need to be open. Will need to be extensible. And those technologies within this domain, which are open and extensible, they are most likely to grow and even survive. Lastly, I believe in terms of use cases, we are still just at the tip of the iceberg. There are many more possibilities that we're going to see. Some exciting solutions are already available in terms of the public transport systems that have been designed, and then there's a very high uptake of innovation in connecting users with the mobility with their environment, right? I'm going to take this last few minutes and just talk to you about again one specific view. The topic is large. There are several solutions available. We at Siemens have got very comprehensive solutions available, starting from designing your vehicles to managing their for their life. But I'm going to talk about how can you monitor connected vehicles, reduce service costs, maximize your utilization. How do you improve your customer satisfaction? So let's just take a look at the small example. So you're a fleet owner and you're running these 9 different electric bikes that are running. So you get a clear view up front that, okay, 7 of your vehicles are connected, 2 are offline, and you'll see that there is an alert. There are 3 critical alerts, and it's the screen will point you that, okay, the alert is on this particular bike. So as a user, you would go and query and see what is the effort, what is the critical issue there, and it brings up the 6 or 7 parameters from this telemetry, regarding battery voltage or the angle road, and it finds out that repeatedly there is an alert that the motor torque is very high. So now you can move into from a connected product to a connected engineering and analysis. You could use technologies like this where you close loop the digital twin to see that what you had simulated at the design and how the unit is performing, is that matching or not, right? So here we just saw a simulated time and the actual remaining time of the battery is good. However, we saw there were some issues that were related to torque. And once the engineer comes in and queries that where the data is showing, now you'll see there's a comparison made between the red line and the black line that shows up, that that was the simulated voltage, but that's the actual voltage the battery is drawing. So which means this could be an indication right from the live working of the vehicle that you need to increase the capacity of your battery. And if you had the design and the simulation model right attached in a connected ecosystem like this, you would go in here as an engineer, quickly figure out how can you take the same design but add more capacity to your battery, and you would initiate a design change right from here. So again, coming back to what I initially talked about, that there are many solutions available, but I really wanted to take this chance, engage with all of you. I look forward to our interaction. This was one example of what connected vehicle can offer. This was an example of a digital twin, how issues are brought up and then fed back to design. So I look forward to the rest of the session. Thank you very much.